All right, example 4. We're looking at the function x to the fourth times 4 to the xth. Kind of confusing to look at, but all that's going to be involved with this is you're going to be using the product rule because that is the outermost operation that is happening first here. So we have the x to the fourth times 4 to the x. We're still going to need logarithmic differentiation in this case. And it'll work out a little bit differently because we're going to have to worry about this product here. So there's one way we could either do it with using the product rule, maybe, or we can just leverage our logarithm rules to make this a little bit more straightforward. So I think the latter way is going to be the best bet. Let's give that a shot, still following the steps that we see below. So we have y is equal to x to the fourth times 4 to the xth. And then what we're going to do is we're going to take the log of both sides. So we have natural log of y is equal to natural log of x to the fourth times 4 to the xth. All right, now we want to use our log rules here. So how do we use our log rules on the right-hand side here? So the outermost thing that's happening on the inside of this log is that these functions are being multiplied. So we need to break this into a sum of logs because that's happening before the exponentiation. So doing this gives us log of x to the fourth plus log of 4 to the xth. So multiplication on the inside of a log gets demoted to addition outside the logs. Hopefully you guys remember this from pre-calculus. All right, now how do we simplify this a little bit further using log rules? Notice that we have an exponent on the stuff on the inside of the logs, namely this 4 and this x. Exponents on the inside of a log get demoted to multiplication. So the 4 gets moved out in front of the first log. So we have 4 natural log of x plus, okay, now this x gets moved down in front as well. So you have x natural log of 4. Natural log of 4 is just a number. Natural log of x is a function. So now when we go to derive this on both sides, it works as follows. Exactly kind of the same way it did in the last couple problems. So deriving the left-hand side, the derivative of natural log of y, that is going to be y prime over y. And then on the right-hand side of this thing, we have 4 times natural log of x. So we need to derive this natural log. So we have 4 times the derivative of natural log. Derivative of natural log of x is just 1 over x. So our answer is 4 over x. All right. Next term, we have x times natural log of 4. Natural log of 4 is just a number, so it's some number times x. So when we derive this, the x goes away, leaving us with just the natural log of 4. Okay, so we've completely derived both sides of this equation. The goal again was to get y prime by itself. So to do that, we're just going to multiply both sides by y. So we have y times this side, so these cancel. And then you have y times the entire right-hand side. Okay, so if you multiply the entire left-hand side by y, you have to multiply the entire right-hand side by y, because you need the equation to balance. So continuing along, we have y prime is equal to 4 over x times, oops, not times, plus natural log of 4 times y. But our y, based on what we knew at the very beginning of the problem, is equal to x to the fourth times 4 to the xth. So writing that in as our final step, we get x to the fourth times 4 to the xth. All these things are being multiplied. And that's your final answer. You did what you set out to do. Your goal was to find y prime. We did. And just by following the steps that you see above. These all work out the same way. You just got to remember your log rules and be very careful about how you use them.